Let's talk about parabolas, specifically using the distance formula to write the equation of a parabola. Okay, so parabolas are defined like this. X minus h equals 1 over 4p y minus k squared. Don't worry about all that kind of junk right now. Hopefully by now you've come to recognize h and k as x, y coordinates. Don't worry too much beyond that. As you play with this in this video and in my next video, you will understand the structure of parabolas a bit more. Now, a parabola is defined as the set of all points in a plane that are a fixed distance from the focus and the directrix. So the focus is just a fixed point, the directrix is just a fixed line, okay? So meaning we pick a focus, we pick a directrix, and we build this parabola around it. It has an axis of symmetry, meaning if I collapsed it on itself over the axis of symmetry, it'd be a mirror image. The axis of symmetry passes through the vertex. And the vertex of the parabola is the midpoint of the perpendicular segment connecting the focus and directrix. All right, let's unpack that a little bit. So, a parabola is defined as a set of all points, so think of the shape itself not as a continuous line, but a set of points that are a fixed distance from the focus, here it is, and the directrix. Here is the directrix. Remember, we choose a focus, we choose a directrix. The parabola has an axis of symmetry, you can see here in green, and that's dictated by where the vertex is. Okay, because our axis of symmetry will pass through our vertex. Now, this vertex is the midpoint, so meaning it's halfway between two things. One, the perpendicular segment connecting the focus and directrix. The perpendicular segment connecting the focus and directrix. Okay. So, here is my directrix. Here is my focus. Perpendicular means a right angle, so if I looked at a perpendicular segment, I'd make a right angle with my line. And you can see that this perpendicular, this line right here, is perpendicular to the directrix, and it connects the focus to the directrix. Okay, so they're just saying that the midpoint of this is the vertex. The vertex is halfway between this line here and this focus. So halfway between the directrix and the focus. Okay, we'll get more into dealing with properties and tables and photos of parabolas. Today we're going to focus on using the distance formula to write the equation for a parabola. Now, hopefully by now you've heard my spiel about the distance formula, where it comes from, why we're applying it in this case, meaning you would have watched my hyperbola, my circle, or my ellipse videos. If you haven't and you want to know more about the distance formula, go tune in to the first couple moments of any of those videos. For now, we'll move forward. So we're going to use the distance formula to find the equation of a parabola with focus 2, 4 and directrix y equals -4. So this is a little bit different from the approach we've taken to the distance formula in the past. However, some things will still hold. I still always like to start off by drawing a skeleton of everything. So I'm going to keep everything in white, and I'm going to leave space to fill in the rest of the information. Okay. So I've got this focus, which gives me an x and y value, but then I've got this y and no x to go with it. And notice that in the equation, we've got x1, y1, and we've got x2, y2. So how are we going to match this up? Well, this focus is going to become x1, y1. We'll use the focus for x1, y1. So let's go ahead and write that in now. So I'll write 2 and 4. Now, what about this other side? What am I going to do with y equals -4? Well, I'm going to use it for my y2 coordinate. So y equals -4. I don't have an x coordinate here's how I work around that. I'm going to write x. Okay? Take a moment to consider that. I didn't just write 0 because 0 would be an actual coordinate. I have no x coordinate. I'm talking about the line directrix y equals -4, right? So if this is my directrix, okay, there's no one x value for this line. That doesn't make sense, okay? It's a line. So we write x. From here, it's a matter of simplifying, but there will be a little bit of a trick to it. So let's start off with some basic simplification. So this left-hand side looks fine as it is. So I've got x minus 2 squared plus y minus 4 squared equals, notice that x minus x is just 0, so that term cancels out, and then I get y minus a -4, so y plus 4 squared. Okay, continuing on. I can't really solve further until I get rid of these square roots, so I am going to square both sides of this equation. When I do that, my square root symbols drop, and I'm left with x minus 2 squared plus y minus 4 squared equals y plus 4 squared. Great. Now, let me tell you this. The goal of our solving here is to get this equation in the form of y equals blank. So we're solving for y. Now, if I'm solving for y, do I care about what x is? No, I don't. So I'm going to expand this equation, but I'm going to kind of ignore x. There's no point in me expanding this x term because, again, I don't care about x. So I'm going to have to move on to another page here. Okay, so this is what we just were working on. Okay, I had this up, and we were just discussing no need to expand that term. Okay, so I'm going to leave x minus 2 squared alone, but I'm going to expand this term into y squared minus 8y plus 16. If you need help knowing how to expand when they look like this, contact me, or keep in mind you can always work around this if you don't remember the rule for squaring by just writing these terms side by side and foiling them, and you'll come up with the same thing. Alright, I'm going to do the same thing to this term. I'm going to expand it. Okay, so I've got all my y's expanded, but I left x alone because I don't really care about x right now. Now I combine like terms. Y squared, I'm going to move the y's to the right hand side. So my y squareds, as you can see, drop out altogether. If I subtract 16 from both sides, those drop out altogether. If I add 8y to both sides, notice that my 8y's don't cancel out. I end up with 16y. Now all that's left, if I want to solve for y, is to divide by 16. So in the end, I've got y equals the quantity x minus 2 squared over 16. Okay, so this is the equation for this parabola. So we first just substituted our values into the equation. We simplified with the goal of solving for y and left x alone, and this is how we got our equation. Notice that it's a little different because in the past we had kind of specific framework that we were filling in values to. In this case, it's just a matter of solving. Okay, let's continue. Okay. We'll do the same thing here. Using the distance formula, we're going to write this equation. So this time I've got a focus of 0, -2, and a directrix y equals 2. Okay. So 0, -2, y equals 2. Let's start filling in values. Now, remember that this focus is going to be x1, y1, and x2, y2 will be x2. I get the 2 from the directrix being 2, and I use the x because y equals 2 for all x, because this is a line. Okay? I've got a line here at y equals 2, so no matter what x value I plug in, I get 2 back. So x1, over here I see x1 is 0. So I subtract 0. I see that y1 is negative 2, so I'm subtracting a negative 2. I'm doing x minus x, and y minus 2. Alright, continue simplifying. X minus 0 is x, so I've got x squared. Y minus negative 2 is y plus 2. X minus x drops out, and I'm left with root y minus 2 squared. To undo root, I have to square both sides. So I'm left with x squared plus y plus 2 squared equals y minus 2, the quantity squared. Remember, in the case where I'm given a focus and a directrix y equals something, I'm going to ignore x and solve for y. Now, take a moment to note that not all problems have a directrix y equals something. So it's possible to have a directrix going, just for sake of theory, you could have a directrix x equals something, in which case we would solve for x and ignore y. So my point of saying that is, when you look at the question, you'll know which variable to solve for based on the directrix. If the directrix says y equals something, you know you need to solve for y in the equation. Okay, let's continue. So I need to expand this. X can't even be expanded anyway, but if it could, I'd leave it alone. Let's move on to the next page here. So this is where we just left off. I'm going to expand this, leave x squared alone. This becomes y squared plus 4y plus 4 equals y squared minus 4y plus 4. I gather like terms. If I subtract y squared from both sides, my terms cancel. If I subtract 4 from both sides, my terms cancel. If I subtract 4y from both sides, I end up with negative 8y. So something to watch out for here, you might get so cancel crazy that you think that my 4y's will cancel out. So if you ever end up with a 0, if everything cancels out, that's a hint that something's gone wrong. So I've got x squared equals negative 8y. Now remember, I'm solving for y here, so I divide both sides by negative 8, and I get x squared over negative 8, or negative 1/8 times x squared. So y equals negative 1 over 8 x squared, and that is the equation of this parabola. Let's do one more example. Okay, so same thing, I've got a focus and a directrix. Notice that my directrix starts with y equals something, so in the long run, I'm solving for y. For now, let's fill in our equation. Last time I went through it kind of speedier, right? So I didn't do my whole skeleton first. I'll go ahead and do it this time, just in case last time was a little too fast. So I write in my skeleton, it looks like this. Now I'll fill in my values. Remember, my focus is going to be x1, y1, so 3 and 5. My directrix will be, since it's y equals, I sub it into my y2, x goes there. From here, we simplify. This side is pretty much already simplified on the left, right? So, just rewrite it. Now, on the other side of the equation, my x's drop out, and I'm left with y plus 5 squared. I can't go further until I get rid of my radicals, so I'm squaring both sides of the equation, and that's why I'm allowed to do it. Because if I square both sides, then they're still equal. So I'm left with x minus 3 squared plus y minus 5 squared equals y plus 5 squared. Remember, since I'm solving, here we are again, picking up where we left off, since I'm solving for y, I'm going to ignore this x term. I don't care that it's not expanded. It's fine the way it is. So I am going to expand my y terms. Okay, so I've got y squared plus 10y plus 25. All right, simplify from here. So x minus 3 squared stays as it is. My y squareds cancel out. My 25s cancel out. I add 10y to both sides, and I get 20y. Now all that's left to solve for y is divide both sides by 20. I get 1 over 20 times the quantity x minus 3 squared. I like pulling out this fraction, right? I could have written it x minus 3 over 20 like that. That would have been equivalent, but I just prefer the way this looks. It matches more with the equation form that you're given in your textbook. Okay? So again, using the distance formula to solve for the equation of a parabola, use the focus for x1, y1. Directrix will become y2 if it's a y equals something, and use the directrix to tell you what you're solving for. So if you've got directrix y equals something, then at the end of that problem you better have solved for y. Remember, no need to expand x if you're not solving for x, just leave it alone.